Yes. Work.
That works.
The clicker is not working, I don't know why. It's quickly because of what you're presenting on. So, yeah, you'll have to. It's not working.
Okay, so the final talk of this session, I think. Final talk of this session, yeah, good. Is Philippa, and she's been working in verification area adjacent to Peter for a very long time, and it's been wonderful seeing their interactions of pub at the time, so I have to say. Take it away, Philippa.
Thank you very much, and it's wonderful to see you all, and there's so many faces that are so familiar and have been so familiar over the decades. It's actually been lovely coming into this room. And I put this title up as a little bit of a piss take, because there's half the audience that are doing a macho industry, millions of lines of code thing. And then what is this academic putting up this, fiercely academic, putting up this title? But actually one of the profound effects of Peter O'Hearn on me and my work has been always to go, right, and what does it mean to take that to the next place? And in particular, that started with, he'd done separation logic, I knew about ambient logic, put it together and got tree logic. And that was my first little foray into separation logic. And Pete wouldn't stop jumping up and down and saying, it's no good, you can't stay in theory. What does it mean to use it? And actually, I had a wonderful PhD student, Gareth Smith, who'd come from practitioner land, and we moved it into DOM update world and ended up getting, beginning to get more practical. And actually, that sort of has always been the start of where I now am, which is this sort of combination of theory and practice. So what I thought I'd do is put up some slides with some very old friends, and at the same time sort of try and show where, given my work, where this step from wherever I am to that next step, to this, how does one scale given where one is to where one is going next, it rears its head in the various parts. It's not scale in that millions of lines of code industry thing. We don't know Alan Turing, but apart from that, we've got photos of friends all through this talk. And basically, we know where our field has come from. And then we get to something like this, where basically we've got the tools that are now mature enough that we can go to the next steps. Not just the tools, the techniques and the tools that allow us to go there. So, for example, you know, the Tony Hall, Robin Milner, also John Reynolds, these type of people, think of their who they were and what they're doing. And now think of who we are now. Very, very different types of people. That's because the field has been able to move because of the greats at the start of what was going on. So I'm going to try and justify my use of the word at scale. And I am going to do it with 3 pieces of work. And we'll see if I manage. Some more than others, I think. We know the beginnings. We know our field. We've got Gordon Propkin doing structural operational semantics, through to Robin Milner doing standard ML, loads of mature proof assistants, loads of partial mechanized language standards that have come after the fact and are not really integrated within the standard, and then Wallop. This is Anders Rosberg, who we've got industry standard where the only way you change the specification is by doing the formal semantics. That's written in to what the standard means, and it happens to be the WebAssembly stuff. And it happens to be small enough at the moment that it's possible to do this. So we've got WebAssembly, which is the language on the web after JavaScript. It's not just about the web, it's going all over the place for ubiquitous systems, but that was their pitch at the start. There was the draft PLDI paper, and then the real industry standard coming along in 2019. And basically, this guy, Conrad Watt, settled it all down in that the implementations were fine using the normal standard process, standardization process to do with industry implementations, etc. But what was not fine was the formal semantics, that in the sense that there were mistakes that Conrad caught before that publication. So thank goodness the formal methods agenda was okay, and it was okay even then because of that mechanization. You know, it was small enough for the mechanization to come in. Conrad I knew very well. He'd come from my gang, and as an undergrad in Imperial, and we joined together and ended up doing Isabel and Koch versions of mechanization for the standard. And in particular, something that just happened last year is that we can prove correct module instantiation of WebAssembly. So here we are on Robin Milner's agenda, and we've got module instantiation that is type safe. And no way was that possible without the mechanization. So it was a hope in the standard, no way were they going to go to module instantiation. And the correctness results for it. So, I mean, in some sense, these are tiny things because we know how to do them. But in another sense, what's it mean to go all the way and do them? And that's been something that we've tried quite hard to do. There's lots of stuff. I'm not going to go into it. If anyone's interested, there's the WebAssembly workshop happening on Monday. Just to say, we have done separation logic for WebAssembly. The killer stuff is this Iris-Wasm work with where we joined together with Lars Berkedel's gang, and in particular, Einer's awesome. That's the summary. And of course, Iris is awesome because of the higher orderness. That makes life very easy. But I want to just go a little bit on, we're in this new place now. So already Anders Rosberg is changing how one thinks about language standard. We've got the operational semantics right embedded in the standardization process. Now we're in a different place with a new standardization process. Not accepted yet, Anders Rosberg is part of it. And so all this gang. And what's been going on is that we have the implementations of a language, it just so happens to be WebAssembly, and we go from that to the standardization process. And then, if you're interested, we go on and do the mechanization. That Conrad's lucky enough that it does feedback, and he did have real effect, but actually you have more or less effect depending on when you do this process. But I want to drill down into this bit a little bit more. So what's going on with this standardization process? Well, for WASM, it is this new thing. It is that you've got the formal specification as part of what it means to be the standard, as well as prose description, test suite, reference interpreter. So what does that mean? It means Anders Rosberg, who has to write the formal specification, or maybe it's Anders and Conrad now, hardly anybody else, you know, that we've got real specialists going on here. They're also having to do the prose. This is a nightmare for them. But we've got a new, and then as part of this, there's the mechanization. But actually, we've got a new thing in town, which is we've got a DSL, and basically the ground truth is this DSL with annotations. And what that means is that the formal stuff, prose, testing, reference interpreter, and mechanization definitions come automatically from starting from here. So we have automatic translations to this lot. Some done more than others that are catching up, but basically we're trying quite hard at least to work out how to keep the mechanization going with respect to the other stuff. There's lots to do. And so we've got a different process of what's it mean to do the language specification. And at the moment, the language definitions are automatically generated, and then we've got, at our leisure, our time to play with the rest. But how much can we actually do? Can we get automatic generation of proofs as well as definitions? Who knows? This is where we're absolutely in the research game rather than in the useful game of being part of the standard. So that is my first place where, what does it mean to be in this tiny world and move to a place that scales? And we've actually lucked out because we went to a Dagstuhl where a certain gang got together. And we'll see what happens. The next one I want to talk about is compositional verification and true bug finding. So, Rob Birstall started this off. It's in some sense, Pete O'Hearn and John Reynolds were reinventing what he was doing, and I think John knew more about it than most because he'd lived through it. But I hope people don't forget Rod, because that actually is, it's a fascinating paper. It isn't all tied down, but our intuitions are embedded in that paper. And then we've got some of these awesome guys who we know, and there's more than enough people to talk about that. But the point is, there's real history. So, these guys, they've been working away, and now the new generation come into town, yeah? And the new generation, let's represent it by these two. But actually, the whole world has changed. They're coming into the wave at a completely different place to where the generations 10, 20 years back were. And so where this is going and how this is mushrooming, we don't know, but it's pretty awesome. I'm playing a little play in here, which is that there's a gang working on unified compositional symbolic execution. And in particular, the key thing is here, which is what does it mean to do function compositionality? And it's something that from the separation logic world, we know this absolutely, it's key and core to what's going on. I don't think it was their key core at the beginning with the originators, but over time, this is the key core thing. And in my world, what that means is the following. You've got a symbolic state, you're doing a function call, you're getting the answer either okay or error. You might have missing, but by abduction sorts that one out. And you've got an incorrectness function specification over there looking like that. And I've done it as a quadruple, not a triple. There's two triples there. Yeah. I've put them together. And we sort of know what happens. It's in all the tools. It's all around, which is we have symbolic state, and we're matching that symbolic state to the precondition P. But actually what we've done is worked out this axiomatic interface between what's going on with symbolic execution and the function specifications. And for me, whether it be in this world or the concurrency world, this has been always absolutely pivotal for me. So in the true bug finding under approximating world, you match by SAT. You keep the frame, and then you produce the result using that function specification, and only using that specification. And we have the correctness result. And then whether it's true bug finding or verification, not so very different. We've got different specifications. We're using implication rather than the SAT solver. And we've got different interpretations going on, but there is no real difference. And in particular, the only place where the difference occurs is in this consume function in one place. And that's when dealing with pure formulae and whether you're working in this SAT world or this implication world. Everything else is just the same. And I imagine the same as one moves to different types of new logics. The one in my head is outcome logic. There'll be others. And the key thing is here, this axiomatic function interface is very simple. It's saying that you're manipulating memory models well, and that you've got some soundness, completeness properties that won't be so surprising. It's nothing to do with how actions interact on memory. It's parametric. It's nothing to do with the particular control flow you happen to have. It's parametric. So in fact, this is that general, one can write down the function call rule in that very general form that basically is language independent. Just having the properties of these bits of memory. And all this was inspired by the Gillian work. So in particular, Gillian is massive thing, full of optimizations, difficult to read, awesomeness. And then we pulled it out to grab at the essence of it here. Oh, by the way, we put in the incorrectness too, but that's just fun. And and to be able to do that, the key step was to do with this guy here, Andreas, this one. He did something absolutely, for me, that was pivotal and awesome, which is he was struggling to get at the heart of what was going on with Gillian, given all those optimizations. And he was able to do it by interacting closely with the people working on Gillian and doing his Haskell implementation. So suddenly we've got the theory and Haskell very tightly intertwined. And then this mass of Gillian showing an example of that. And in particular, we could get at the heart of what the consume and produce and matching were doing and show and prove it was correct, captured by that Haskell implementation. So now the question is, we've now moving from Haskell to Gillian Cog. So in particular, we've got, again, that simple thing linked to the theory. And then what on earth does it mean to relate that to actually this rather impressive optimized Gillian work? So one thing we're toying with, but it's play, because we don't know what's going to happen, is can we generate proof logs to hook into Gillian cert? But actually that's not so very different from what was going on with the WebAssembly work, which is can we, as well as automatically generating COC definitions from the WASM DSL, Can we also generate proof logs from the WASM DSL? We don't know, but these are the questions we're asking. So Gillian is very much in this parametric place, parametric with respect to memory. What we want to do is make it parametric, not just with respect to memory, also with control flow. That is on the way. It will take a little while. At the moment, we work with one intermediate language. So, and we've got these instantiations that are really rather macho. And this thing of where does one go, how does one go to scale? Well, I think that this example shows it rather well. Petter and Sasha here did verification of AWS code, and there's a whole story there that I'm not going to go into. But what is so macho about it is that they've taken this high-level specification of a message deserialization header. And it's very, very dynamic, and it's this high-level specification. And what they're doing is they're going to the bytecode representation. And the interpretation is happening in this dynamic way. So this is, many tools say, well, we've done that bit of industry code, tick, especially the academic tools. We want to do that, we're doing it. But I think this tick is rather a good tick, and I think that what they've done is rather special. Yes. Excuse me, Nat, I'm going to dip over your demo. It's also going to be around at the end of the week, so I'm going to just dip it now for time reasons. I'm so worried about this music. But the main thing to say is that Sasha has been working on debugging for about 4 years. Nat's come along doing an awesome MSc. And he's taken DAP, done symbolic DAP. We're doing it, we're looking at what is the right debugger for Gillian verification at the moment. And I'm so delighted. Nat is going to do a PhD, and his external supervisor, Jules Villard, who's just given me permission to say that. And so you can guess where this might be going. No, don't hide that. That was Matt saying. I've got one last thing, and I've got about 3 minutes to say it. So let me try. I'm not going to say very much about concurrent verification, compositional verification for concurrent programs, because there's a lot of people that can talk about that. But I do want to emphasize something. So here we're talking about thread compositionality and function compositionality. You've heard about function compositionality just a moment ago. And about proof reuse. What does it mean to be in the right abstraction to easily use your reasoning. And here are some of these guys. So basically, concurrent separation logic got the thread compositionality. Here we got the function compositionality and beginnings of abstraction. Still, the abstraction was not right. And the way we found that was we did a big jump. And looking back, it's an impressive jump, which is we, at the time, could do concurrent B trees. And that was way off what people were doing at the time. Now it's peasy easy, but it wasn't then. And this is, again, an example of that scale, of where you are, where do you go to, and where do you show where things are breaking. And basically, we weren't getting the abstractions right. And we got them right here. and so went all the way to skip lists in Java util concurrent. So again, that's not just concurrency, concurrent B trees, it's let's do something madly big. This is all handwritten, right? This is mad. And it was fun. And now we've sort of pushed the boundaries of what's possible. Some of the ideas evolved into that wonderful Iris framework. And, that's mushrooming out hugely. But notice the word wonderful as the adjective, because I'm just about to go, yes, but. So we're here. We have Emanuele and Julian putting in the liveness stuff. Things began to break here, in the sense we're pushing too hard on the handwritten stuff. Here, these guys showed that there was some stuff. No! 2 minutes.
Do you have a concluding slide?
Yes.
Do you have a concluding slide?
Yes. No. Wait, Lily, don't be, no. I have a point. So, I'm wanting us to challenge what's going on.
It's not me.
Because, let me do this challenge. Because we're not simple enough. We've got this huge iris. It's wonderful, wonderful foundations. It's awesome what they're doing. Yeah, we can see the awesomeness to do with Popple, but we also have to go the other way. So I've just started again thinking about the other way. How do we actually simplify? You have to let me do this. So I have a green and gold lame chair in the room. The reason for this is because of Thomas Dinsdale Young, who made the chair, as well as his bow tie. And this is to do the awesomeness of Thomas that you are going to let me say. And now I am done.
Thank you very much, Philippa. You managed to fill even all the extra time you had. Does anyone have one question?
Right. I want to have a bit of fun with you, like we would have done over the years many times. So this work on WebAssembly, where you're specifying it. Now, suppose I was a VP in a major tech company, not an academic. So it makes us give us a warm, fuzzy feeling to have done all this work, to have done that spec. But somebody in the industry there's this word impact. They'll say, what's the impact of having done all that work? I have an idea, but I'm wondering what your answer would be to that question.
Conrad. Oh, yes. Conrad has had the most enormous impact because he made the standard correct.
But what's the impact of making the standard correct? What if we didn't do that? Think of the deletion test. What if we didn't do it?
Getting the formal methods agenda into the standard, and people like WebAssembly because of that. And in particular, I was talking to a guy, he's CTO of a big company, and he just happens to be a neighbor. And so he knows all about this WebAssembly, it's blockchain company. And he really would like to use the WebAssembly stuff. He was talking about what are the inflection points of WebAssembly. So we're not at the inflection points of WebAssembly yet, but we're on the way. But what he never once was concerned about was the formality of WebAssembly. He's saying it's essential. So it's sort of flipping the other way a bit. And then how is that going to go? We don't know until we know what's happening with WebAssembly. But in particular, what seems to be happening with WebAssembly, with a little bit of cross fingers, is that the standard process, dilatation process, is changing right now, in the sense that Anders and Conrad really would like this WASM DSL stuff to happen. It's not accepted yet, so we don't know, but they really want it because they don't want to write prose by hand.
So it sounds like I have an idea for what the impact could be, but I'll tell you offline. But it sounds like WebAssembly has not yet had major impact, so it's hard for the specification effort to have major impact.
I think that's not fair.
That's what I was reading.
Yeah.
Your answer. That's what how I interpreted
so I think
your
the
answer.
point is, what's it mean to take WebAssembly to be these specialist people working on WebAssembly to every blockchain company is using WebAssembly. Yeah. Why should they be? Because it's the only major language on the web where you can run C code videos.
Don't make me play the music. Yeah. Cool. Let's thank Philippa again.